Hello guys, welcome to another episode of this series where we build a URL mapper web service using Rust. In a previous episode, we looked at how to build UI to basically allow us to be able to manage our URL map data using the CRUD API that we built previously. Today, what we are going to be looking at is how to do something similar, maybe something even better technically with React.js. Now, there are going to be a few things different in the whole workflow of how what we are going to deal with React.js as compared to the vanilla JS. And that is that if you remember the vanilla JS project, the HTML and the assets, they were basically being served from within our Rust application. Now, the recommended way, of course, is as far as the static assets go, they should probably be served from directly from your web server, your own, something like Nginx, because they do a better job. Or an even better way would be to actually host them on some sort of a CDN. Again, they do a better job at both caching and serving them really fast, and they're optimized because they have very good geolocated caches and everything. However, coming to the point of difference between the vanilla JS approach and the React JS approach, the fundamental difference for us, especially in the development mode, is going to be the fact that the React JS is going to be running its own service on, and it defaults to port 3000. It runs its own service where you also have your webpack dev server running, which allows us to do hot code reload, which means that any change we'll be making to the code would be instantaneously reflected and we would be able to see them in the UI, and that turns out to be a really good workflow. In our vanilla JS approach, we also had something close to that, but we still had to refresh our pages. But with React, with Webpack Dev Server, we would not have to do that at all either, because it sets up a WebSocket connection between our front end and back end, and then make sure when assets have changed, they hot reload and send the actual stuff directly to the server, and things are refreshed automatically for you. So things are much easier and faster in terms of the development workflow goes. So since that's how it's going to be, what we'll be doing is, so we'll let the React.js be a standalone service on its own. And what we will do is we will let it run on its default port 3000. We will instead then run our backend service on port 3001. And so here, because we will be communicating on different ports and the front end would have to communicate to the backend using Ajax, what we will also have to go and set up is CORS. And CORS basically, to give us quick primer, is basically cross-origin resource sharing mechanism. That basically it's a security mechanism, and by default the way it works is basically any request that comes from a host that is not the same as the one that is receiving the request is rejected. In order to control who gets to access these APIs, who has access to the data that the APIs serve, we will then have to set up our backend application to be able to service specific headers, which allows us to control and allow the requests coming from certain specific websites, and so that will allow the front end to be able to communicate to the backend. And there's also a little bit, without going into a lot of details, along with the regular Ajax, there is also a pre-flight request that happens when the browser makes. Usually the HTTP method for that is options, and these are made to sort of quickly check the server, whether the server allows the Ajax request or not. And so we will also have to make sure that our backend deals with them and allows the request to go through successfully, because those need to be, unless we respond back with an HTTP 200, the front end will not even go and make the actual API call. And so the first thing we will be doing is setting up our application so that we serve these HTTP headers, which allows us to work with CORS. And let's see how we can do that. We will have to be going and basically changing up our main router. And the way we will be approaching this, the cleaner way to approach this is basically, because these headers should be present on the responses that our server is sending back, right? And so what we will do is we will write a post middleware and mutate our response and inject these headers, the ones that we need, and so that it becomes the headers then are applicable, and then our cars would work. So let's see how we can build a simple post middleware. We're going to call it cars, and this basically receives a response instead of a result, because it's a post this thing. So we want to mutate the response, and this should return a response wrapped in a result, because again there may be potentially some error introduced by the middleware depending on what you do. So to allow for that, we must wrap it in a anyhow result. And what now we will do is we will get the actual headers, and then we will mutate them. And how to get the headers is, we can use the method headers mute, and this gives us a mutable reference. Once we have this, then we can simply use the insert function to actually insert header variables. So the header would be allow access control origin. We want to import header value, because this is what we'll be using to actually set the value for this. And so it's going to be header value from static. So to make things easier, we could use a wildcard value for this, when that implies that the request coming from any host is allowed, which is obviously dangerous, and so maybe we'll not do that, but I wanted to let you know that this is common, especially for development. This is commonly used. Instead of this, we will literally say, okay, because we know that the requests are going to be coming from localhost 3000, we will specifically say that, okay, hey, this is the one that is going to be allowed. And similar to this, we will have to insert a bunch of others as well. We'll allow the headers, methods, the expose headers, and now we will forward our response. So we have to, in order to actually access the headers and mutate them, we have to declare our response as mutable. So now once we have this, then we can go ahead and add our middleware. Like I said, we'll be using the post one, and that's it. So this will ensure that all the requests, all the responses that will go out from our server will send out these headers which are used for the access control. And the next thing I said is, in order to get the pre-flight working, we'll have to also make sure that the options requests go through, and we'll do this specifically only for an API. We'll worry about there, because those will be the ones we'll be calling from the front end. We basically want to not worry about authorization for those, because they're not used for any data exchange. They're only basically used as a way for the browser to actually check whether the server allows these requests to happen or not. And so we will just basically simply allow these requests to happen, and so we need to send back an HTTP 200. And so for that, we can simply we'll get the request method, and we will make sure that if it's options, then we will simply just let the middleware go through and not do anything and not worry about anything. And so we will simply forward the request, and yeah, so this way it'll always send 200 for all of our options pre-flight checks. So this will make sure that our front end would easily be able to talk to our backend. And now like I said, we'll be running our backend on port 3001. And so now let's just run our service, right? The service is up and running. We can quickly use our curl interface to check if it's running fine. Yes. Yeah, everything seems to be running fine. The important thing to note here is the fact that we are sending out these headers, these important access control headers, which will allow our front-end application to actually talk to our backend application and get the data that it needs. Now we will go to inside our client folder. Here we will now create our React application. And so the recommended way to create and easily create a React application is to install an application called create React app, well-known utility that allows you to basically bootstrap, with all the boilerplate and everything. So we don't have to manually do anything. It saves a lot of time. So I've already installed create React app. So what I'm going to do is I'm going to basically just invoke the create React app, and I'll be calling our React application as React mapper, or maybe we'll call it React URL mapper. What I'm going to do is, for my own sanity, we're going to be developing this in TypeScript rather than JavaScript. There are a lot of benefits of using TypeScript instead of JavaScript. TypeScript is a type language, and it has very good type inference and everything. The biggest advantage that you get by using TypeScript is we're able to detect and capture a lot of very commonly made mistakes when using JavaScript, because there's no type checking there. You can make a bunch of easy mistakes, whereas when you're using TypeScript, because it's stricter, it enforces you to actually make sure that your types are more well defined, and if they're not, it also gives you warnings and things like that. So basically the compiler helps you out a lot, and you're able to catch a lot of bugs and issues at compile time rather than having to debugging it within your browser at runtime. So it saves you a lot of time. So we'll be doing that. So there we have it. We have our React URL mapper, and we'll get right to the initial source that is generated. Like you can see, basically it mounts the React application onto a document root, and our index.html is the one that serves this. This is where the root div is. Another thing we'll be doing is I will again go and add pure CSS, just like we did for our vanilla.js application. I'll be going and using pure CSS for our React application as well, to keep things a little bit more consistent in terms of the UI. And so once the application is mounted, right now the only React component that has been built for us is the app component, and right now it renders an app with this logo and everything. Let's actually get it running and let's see it in action. So we can just invoke npm start and have it running. Right, so this is the default out of the box that you get. So before we get started, one other thing that I'm going to do is, the approach we had for the vanilla.js was we had separate HTML pages for the creation and other things. But since React, this is a standalone separate application, what we will instead be doing is we will actually go ahead and create an SPA, which is a single page application, which means that then we'll be able to easily navigate from some page to the other page. And in order for us to do that, what we will be doing is we'll make use of a library called React Router. And in order for us to get it working with TypeScript as well, we'll also have to install those types. Let's also open the React Router's documentation. Let's go to the web documentation. Yeah. And so these are some of the basic examples here. We'll utilize this basic example actually to get something going for us. So what I'm going to do is I'm going to remove everything from the app. Right now what we have, we will build our own thing. We also no longer need the logo technically. Let me delete that as well. And now we will import the things that are required. We will be getting the browser router as router, just like it mentions in the documentation. We will need the switch to actually render the components. We will need route, and instead of link, in fact I will go ahead and make use of nav link. Another thing I want to do, of course, is remove all these unnecessary semicolons. I really don't like them. Now we have this. What we will be doing is we will create a router, and we will now first create a navigation. So yeah, let's get started with that. I'll use pure menus, pure CSS menus for this to make them look slightly better. These will be the individual links. Right now I'll keep only two things here. One, of course, would be our home, a link to home. Yeah, so that'll just be the root of the application. So home. And the other thing I will have is we will have a separate settings component. This is where we will put our authorization details. Let's see what this looks like. Let's go to our app, and yeah, you can see we have our the menu here. Now let's actually add the components. So we'll step by step build the components that are needed. The first one we will build is the settings. This would be the component where we do our authorization, but create our settings now. So we'll have this look very similar to our original build thing. In fact, I'm going to copy this over for authorization details. Oops, yeah, there's a typo. So when we go to settings, what we see is, yeah, we see our so now, yeah, so in order to actually save this value, like we were doing it in our vanilla JS, we were saving it, saving the actual value in local storage, and we'll go ahead and do that as well here. And so that way we'll be able to actually access this value across different areas where we'll need to refer it. That works out fine. The other approach would be, basically, if we wanted to share the state of this component with other components, would be, to use libraries such as Redux. And it's obviously a complex piece of this thing, and there's a somewhat of a steep learning curve, because it has a lot of moving parts. But for our simple application, I think that would be an overkill, so I'll not be maybe making use of that. However, to give you a context, basically you can utilize something like Redux to basically be able to share state across components, and in an easy fashion. And then also it allows you to decouple your component and your state in a fairly nice manner, so that by means of reducers you're able to manipulate your state, which is outside of your components itself. The components will not be doing a lot of that. And so I think it's a very good design pattern. And but for a more complex application, I would definitely be using it. But for a simple one, we'll probably avoid doing that for now. So now, in order to use state in our functional components, we'll be using React use state API. And what this allows us to do is basically it allows us to create a couple of variables. One would be the auth token itself, and then we also get a function set auth token, which allows us to actually save this value. So for the timing, we'll keep it like this. Maybe the default would be an empty string. Let's do that. Now, in order for us to actually save this value, we will have to utilize something, another hook on React, which is called use effect, because we want to be able to save this in local storage, which is basically it's a side effect, right? It's something from a functional point of view, right? It's something we are doing is we're changing something in the outside world, and so the standard API for functional components to be able to do that is using the use effect handler function, use effect. So we get that, and we will basically use this and do something like this. So this, we will give it a function, and here perhaps we will do something like window dot build storage dot set item, right? And we will just basically be able to set this right now. I set this like this. Yeah. Now the other thing we also want to do is, of course, right now the input we have to actually receive the value for authorization doesn't actually set the value to the token. So what we will do is, instead of the value being just empty, we will bind it to the auth token variable. And now we will also define an on change handler on this. And this would simply be setting the auth token based on the value we get from the component. And this way our state would easily change as we make change or type things in the UI. Technically we don't need a save button anymore, because as we type stuff, we'll automatically be saving them, right? The only issue here, of course, we'll see that. So if I have, like, let's say AST, now let's open. But now if we were to look at our local storage, you'll see ASD is already in it. So technically we don't need a save button, but I'll keep it for aesthetics. In future we may, I don't know, may have more things in this setting, so save button would be saving all of them, things like that. if needed. And also, of course, if you're not using local storage, if we're using actually something like Redux or whatever, again, a save button would be the one that will probably be dispatching that action and things like that. But the important thing to see here is that the local storage actually has this. However, if we were to refresh our application, you'll notice that the input doesn't have the value anymore. And if you look at the local storage, that also gets reset. That gets reset because the use effect will go and set it to the value of our token, which happens to be empty, or an empty string to begin with. So what we'll do is, instead of this being an empty string to begin with, we will instead get it from the local storage and use that as the initial value as well, just so that we can always have the correct value in it. And we'll just return this, and let's see the error. It says basically that since auth token may be yeah, because what happens is get item returns either a string or a null. So basically we'll just use this to say, hey, it'll always be a string, got set to ASD. Now if you look at our local storage, we have ASD, but if we did refresh our application, we will see that it remains ASD. It doesn't get reset, and so we're able to actually utilize it in a meaningful way. Now let's actually get the real value. Yeah, let's get the actual value, and we will use this. As you can see, our authorization has been set. Now we can go back to our home and work on that. Now we will work on the actual home. Here what I'll do is basically we will have our URL map index, right? So we will create a component called URL map index, and we will be rendering that here. So what we will do is I'll create a folder for all our URL map components, and here I will create my index component, or let's call it URL map index. Yeah, and just to begin, but as you can see, we are rendering our empty div one non-likelihood. This is our root, this is our menu, and then we have this empty div, right? Settings we have, and then we have home. So awesome, now this works. What we want obviously here is to actually render our URL map data in a table. We see that our table is rendered here. In order for us to actually render the data as well, we'll have to make the API call. And now instead of doing all of that here in this component, what I'll do is I'll create a separate directory first of all to keep all our API stuff, and here we will create our URL map.ts, the TypeScript file which will have all our functions for dealing with the URL map API. And basically our request will go to, like I said, we'll go to localhost 3001. That's where our app is running, right? And so for that, set this API host, and we'll use this. Now instead of having an hard-coded value, what we will do is we could go in and create a .env file, and the convention is you can keep your data here, and this will be loaded, and then you can access it. However, since I just created because it's an env, in order to actually load it, we'll have to restart the server again. And so now let's think about building the actual API layer. Now the function that we want to build is get URL maps, which should basically return a list of URL map. The logical thing to do is we will create an interface represent the type of data that we'll be receiving from the server. This will make things a bit easier for us. And so for instance, we can actually must return a value. It's just saying that we must return a value. Let's satisfy the compiler. Then yeah, it actually should be within a promise because it's an async function. Yeah, so yeah, so this is the correct type. As you can see, basically it allows us to define our types a little bit more nicely. Here I am being explicit, however this is not necessary, and we'll probably remove that a little bit later. But let's get to the important bits. Now what we need to do is we need to use fetch to build the API, and but then there will be a couple of headers that we want to add to each request. So instead of doing it manually every time, what I'll do is I'll create a helper function saying build headers, yeah, is this headers, and we can just say basically set we'll have to set the content type to application JSON, and we'll the other thing is we have to set up the authorization to some auth token. And what is our auth token? We'll basically just get it from local storage. And as you can see, basically, when we look at the type of this says, basically this is a function that will be returning headers. And so we didn't have to be explicit about the return time, and we'll try to do something similar for our get URL maps. But now that we have built headers, now we just have to basically make the API call. And since we're using an async function, we can make it a little bit nicer. And so we will say our response is going to simply be await using fetch. So we'll use the API host here, and it will be API / URL maps. In fact, there are two ways. So we can now just return response.json, which the JSON basically gives you a promise any, and since we've defined that our return type is going to be a promise of an array of URL map, this automatically get casted to the type. However, if we wanted to avoid doing this, I mean, just as a reference, then what we could do is we can actually then assign it to a variable and say, hey, this should be of type array of URL map, and then we can return URL maps. And this is kind of equivalent. So now we have built the API. Let's import it. So we will be needing I think I'll import the URL map interface as well as get URL maps. And this is going to be, yeah. And obviously we'll need to have state, which will maybe hold our data. Let's import use state for that. And so we will say we will have URL maps and set URL which we'll get from use state. And what we want to do now is, again, we want to make use of use effect to actually make the API call. Get the URL maps, and then we'll simply be set the response, because we the result what we will do is we will set the default value to be an array of URL map. So now that we have this, all we need to do is actually build our table rows. So let's do that. The idiomatic way would be we'll create a separate component for this, and perhaps this is going to receive a URL map as props. In fact, I realized this just now. This is going to be a little bit of an issue because URL map basically has a key. However, in React, key has special meaning, and so we cannot use that. And so for working around that, what we'll do is we'll create a separate interface for our props. So instead of this being a URL map, this is going to be URL map prop. And what this needs to return is basically our table row. And the third one is where we'll have all our actions, and for the time being I'll just keep one. Import API host for APIs. So API host / map dot key. Target would be blank. Key, I use key, it's not key, it's keyword. Our rows is basically we'll just use the URL maps, return a URL map row. Keyword is going to be URL map dot key, and the remaining will just inject directly into the component. This should be good, I think. And yeah, we're already showing our data here. They happen to be no data. We want to show something else, and so we can conditionally check, hey, if rows dot length happens to be 0. So this way, even if we had no data, it'll look a little bit nicer. So we have an empty thing, we have this thing. Now we are rendering our actual data. We should be able to test it as well now. Obviously it works. So now the next thing what we want to do is maybe we'll work on the create page. without worrying about anything else, let's just see this in action. And so I'll be importing our path for this is going to be, let's say, URL map slash new, and this should render the new component. That's what we want. Now, how do we navigate to this? Yes, now let's also fix that. So our index currently has a hard-coded link, I guess. Yes, it does. So we'll fix this. Now, instead of using an anchor tag, we will from React router DOM basically just say here link to, and this is going to be URL map slash new. And when we click on this, as you can see, we actually went to our form. So now, obviously, we are not doing anything. We need a few things. One is we need an API to actually save them. And then we also need to utilize state here. So we'll create two separate states, separate for the key and the URL. Let them default to empty to begin with. But bind the key here, and we'll use the onChange handler to actually set the key, and then actually make the API call. So right now doesn't do anything, and that's perfectly fine. But this is a function. And let's first build the API now. We need the API to do creation. It's going to be a post request, and also that we need a body, and the body is going to be so we'll pass in the actual URL map here. API should give us back the created URL map, and this will no longer be an array, it'll just be a URL map, and we'll return the created URL map. So we have create URL map, so inside of our handle submit, and this will actually create. And now what I want to do is, once we actually create the URL successfully, we'll go back to the home page, and in order for us to actually go back to the home page, we'll have to use the use history hook from React router. And so how this works is we can have the history, and we can simply say history.push. So we need the actual event, and we want to prevent it from doing its thing. So the event is a React form event. It's a synthetic event. It's not the actual browser event. Let's truncate. Okay. So we refresh, and as you can see, we have no data there. Now we'll create github.com, and it navigates to the home page, and it shows it to you. Let's test it one more time. Great. Let's go back to the home page. It shows you the data. Now we'll work on the edit part. For this, again, I'll create a separate component. What I will do is, instead of the URL being just /edit, we will instead use params. So I'll say, hey, my edit URL is going to be URL map /edit/id. So let's get the let's actually get the ID from params, and for that, what we will use is we will use the use params hook. Comes from React router. We need to explicitly tell it, okay, that this is going to be the type. And what I'm going to do is we'll use this as our initial value for the key state. And now we will implement the effect to actually make changes. We'll build in our API to get the URL map. That's it. Yeah. So let's import this as well. So we get our URL map API, and what we will do is do this, and then I will now set key. Yeah. So we'll get the, or this needs the key. So let's and we will say, yeah, key is a dependency actually. Yeah. So as you can see, basically what this will allow us to do is, when the component renders, it will actually get the data from the API, then populate our form, because those values are bound here, and then we could obviously change those values. When we change the values, they'll basically change our internal state, and then finally when we do the submission, then we'll actually be able to update them. And that's about it. let's import it. So we have this, and our handle submission needs the event as well, home event. So we can prevent default, and then we simply call key is key, URL is URL. This should work. Let's add the link to edit. That will be in our index. So here, not here, sorry, it will be inside the URL map row, right? The row should have the edit as an action, and we're going to use link again. So we've added the edit. It looks a bit odd. I think that's it. That's good. Let's go to this, and you can see that here as well. And like you can see, and we'll see the network tab as well. Maybe I'll refresh just to show the network call. Yeah, so this is the pre-flight one, this is the actual one, and as you can see, basically return this thing, and we're able to actually get the data and map it and show it here. It says create. Let's fix that. It should be save. Bam. And let's try saving it. Save, and it goes back to the home page like we said it to. And yeah, it works. Think about the cancel button quickly. So let's maybe add an on-click handler, and what we want to do on the cancel is I think just go back in history, I guess. Yeah, let's look at the history API. The history is mutable, moves the pointer in history back by any entry. So we can literally say so go back is saying go -1. We could do go back. Yeah, I think go back is nice. We'll do that, and all we need to do is history.go -1. And this is the edit page, so we'll test it on the edit page. We'll go home, let's edit LinkedIn, and I'll say cancel, and it just goes back. We'll reproduce this in now. Let's implement the deletion now. All I'll do is I'll return response okay, letting me know if it was successful. This should be good enough, and we don't have that. Yeah, this is good enough. So let's go to our index, and we'll add the action for deletion. Now we want to obviously call the delete API. Keyword. Let's do like a confirmation. Only if the user confirms, then yes, I want to do this, then we will do this. So let's go to a database, and I'll truncate this again, and let me go to create. Let me say cancel, or it does do this. It's like a bug, I guess. I think let's build this separately, and we'll do the prevent default. I think that's most likely what we need to do. Okay, so there are no URL maps. I go create, and I'll go cancel. Yeah, it works. LinkedIn, delete. Are you sure? Yeah, I'm sure. Please delete it. Oh, yes. Okay, so it didn't actually refresh. So let's work on that. Let's go back to our index. So we can't delete, but we want to refresh it. And so the best way to do that is use history.go 0, because this re-renders the route. We obviously need history. We have history, and we need use history, right? Okay, I will quickly create LinkedIn again. Go back, delete. Yes, please, I'm sure. And yes, now you see that it refreshed the component, and we no longer have LinkedIn. So that covers deletion, testing, edit, all our basic CRUD APIs. The nicer thing, of course, is we have proper React Auto, which means we can do something like this. We have separate pages, and we can navigate through them a little better. From a user experience standpoint, this is definitely far better than the vanilla JS one. Also, this is much faster. We can probably do a bit of memoization, to improve, and it would definitely improve our FPS of our application. We could do a bit of memoization because we are fetching the same APIs, the same data. As you can see, we easily been able to create a really nice looking API that is able to talk to our backend. We looked at how to handle cores pretty easily. We also looked at then how we can make this entire thing work, and I think our app is structured nicely as well. All right, guys, thanks so much. I hope you liked it.